Power supply is kind of like a transformer, except what it does is it changes the AC into DC. Okay? And then we have the VFDs. Now, VFDs are a fairly new thing. We are using three-phase motors for to drive everything. Why three-phase motors? Because there's in a three-phase motor, there's nothing in it. The armature is a solid block of metal. And then there's coils around it, but there's no contacts, there's no switching elements. And three-phase motors are just like the most brutally resilient pieces of equipment you could ever see. I mean, they take incredible overloads and crazy stuff like running the motor at full speed forward and then doing what's called plug reversing and just throwing it into reverse at full power. And the motor stops and starts and goes in the other direction so fast, if you blink, you missed it. You can't even see it come to stop. It happens that fast. So now the issue is that the motor speed is a function of the frequency of the power that's being fed to it. And in the U.S., our power grid is 60 cycles. In Europe, some places it's 60, some places it's 50. 60 is actually more efficient than 50. There's about a 10% improvement in efficiency over Europe's 50 cycle power. But that no longer matters very much because we can control the motor speed by controlling the frequency of the power going out. And so what does a VFD do? Variable frequency drive. First step, believe it or not, is to take the three phases of AC and change it to DC. They use diodes to change to DC. Now, that seems counterintuitive, but we convert it to DC, and then we use multi-step transistors to convert it back into AC in a sine wave. All right? So this can control the speed of a motor and the direction of the motor of a standard three-phase motor. All right? And they're quite efficient. They're up around 95% efficient, so there's not much losses there. And in a lot of cases, you save a lot of power because a lot of times motors are way oversized and for the load that they're driving, and they're still operating at full voltage, whereas with a VFD, it actually measures the power that the motor is using and will reduce the voltage to the motor. It'll keep it running at the same speed, but it'll reduce the power to the motor and you save a lot of energy. So that's why you see a lot of VFDs going. Now, as I was saying to Alex earlier, last night I was reading up in machine design and they were talking about using a VFD like this. This one can take single phase AC and convert it into three-phase AC because the first step is always changing it to DC. And so if you are building a portable piece of equipment, the biggest motor you could use on that equipment typically would be about 3/4 of a horsepower because of the starting surge. The motor trying to start would trip the circuit breaker. Well, if you use a VFD and you control the starting current with the VFD, now you can go 1.5 horsepower. So you can have portable things that have twice as much output simply because you're controlling the start of the motor. So that's becoming a common thing. Now, commercial laundries, they no longer have gear drives and stuff. They use a standard VFD, single phase or three phase, to turn the drum in washing machines. And you know how the horizontal machines go back and forth? They're just switching the direction of the motor and it goes back and forth. And in fact, this PLC, and not the little ones, but these actually have a small PLC built in. This can have some inputs that are like tell it what to do. So the laundry guys have gone to VFDs on the commercial laundry machines and they just have the program for the whole machine is within the VFD. They're custom programmed and they put a custom program in it, and that's how they run the washing machine. Now, the cool part is they can control both speed and direction, so the washer can go back and forth at a slow speed, but then when they're ready to do the spin cycle, they can really whirl that motor by taking the frequency up. Now, our standard frequency is 60. These particular drives, these will do 900 hertz, right? From 60, so that's 15 times higher, right? 15, is that 10? Yeah, 15 times higher. So what that means is that now motors lock with the frequency on AC. So a 2-pole motor, which is rated about 3,600 RPM, can go 15 times faster. The motor would probably explode, but that's
bearings can.
No, but this is how the spindles on both your CNCs work. The spindles the motors are actually 3450 RPM motors, or well, it depends on whether they're synchronous. But anyway, they're 3,600 RPM motors, and the VFD takes it up to 180 cycles, and you can get up 10,000 RPM that way. And that's how that's been the big change in machining, is that the VFDs have allowed us to run the motors very fast. Now, from our point of view of building stuff, the VFDs have an incredible amount of programming that you can do. Out of the box, you can get them running with 4 or 5 entries, parameters. You tell it how big the motor is and how many poles the motor is and what voltage it runs on, and then it'll run. And usually you can run it from the keypad here. But then there's about 400 other parameters that you can set. And you look at it and you say, what the hell's all that? Well, there's things like, what happens when the power fails? What do you want the motor to do? Okay, you want it to, when the power comes back on, you want it to slam to a stop? Would you like it to, what if it's still spinning, right? And the power comes back on. Well, there's a choice like, well, it's still spinning, so I want the VFD to match the speed of the motor and then bring it back up to its normal speed, right? Or I only want to do that if it's off for such a length of time. If it's below this speed, I don't want to do that. So there's all these parameters to adjust things. Acceleration rates, deceleration rates, ramps where you can go up and hold at a speed and then go to another speed, that kind of thing. So there's just incredible amount of stuff. It's a pain in the ass because the manual for this guy is 400 pages long, and this is a simple one. It's only 200 pages. And we have to be real careful that we haven't missed anything, and that. So now, fortunately, there's ways to download the program and save it to put it in another one. Right? Now, Andrew programmed these two. We had some issues with things not quite working right, and he made some changes to the parameters, and we got it working. It was XL, decel, and stuff like that. And so VFDs are a real game changer, because then the next level above VFDs is a servo, okay? And a servo is, in the case of AC servos, is a VFD with feedback from an encoder, so it knows position and velocity for real, okay? So in most cases, high-end, this is fairly high-end drive, you can pretty much simulate a servo with this. In fact, on that machine, we put encoders on it so we could stop at the right place, okay? And that's like servo-like. We can get really close with it, and it's not as good as a servo because it's not exactly locked, but it can get really good. But the servo is basically nothing more than a VFD in the case of AC servos.